Hi everyone, I am Dr. Gopi Krishnan, working as Associate Professor in the Department of Aerospace Engineering at SNS College of Technology. Now I am going to give you the video lecture on fatigue and fracture mechanics. This is going to be the syllabus for the subject fatigue and fracture mechanics. From the unit number 1 to unit number 5, the basic concepts of fatigue of structures are explained, and what are the statistical aspects of the fatigue behavior and what are the physical aspects of the fatigue behavior, and beyond what are the mechanics behind the fracture when you are applying the fatigue loading over a given specimen, and what are the different types of testing methods for the fatigue failures, and what are the design for fatigue life. All these concepts will be explained from unit number 1 to unit number 5. These are the reference books and textbooks for the subject. Let us start the unit number 1, titled as fatigue of structures. This is going to be the syllabus for the unit number 1, fatigue of structures. It starts with the SN curves, that is stress with respect to the number of cycles curve, especially for the fatigue testing. Endurance limits we will be discussing, and there are going to be three relations with respect to the testing of fatigue and the prediction of the fatigue strength for the given component. That will be explained later, which is named as Goodman, Gerber, and Soderberg relations. The concept behind the notches and stress concentrations will be discussed, and the different types of stress concentration factors such as the Newberg stress concentration factor and plastic stress concentration factor will be detailed, and the SN curves for the notched specimen and what are the impacts of the notch over the given materials will be discussed, and the composite materials and their nature with respect to the fatigue will be described in the unit number 1. Let me start with the basics of the fatigue loading over the given component. Let us start with this introduction on the application of forces over the given material. And in this picture, uh, two different forces are acting over the given system, and this component can be taken as a system. So the forces are acting in the perpendicular direction, and the forces are collinear. The forces act in a single line but in the opposite direction, and there are two forces acting over the given component. And when the load is applied over the given component in terms of force, the component gets compressed. So when the component is compressed in this way, the nature of the application of force can be called as the compressive forces. This is going to be another type of application of force over the given component. And from this analysis file, we can see that the component is elongated to a certain distance, and after that it reduces its cross section at the center, not at the exact center. It depends upon the property of the material and the application of load. And after the material gets elongated, the cross section it gets reduced, and the material finally gets into a fracture. So this is going to be one phenomena what we are going to discuss for the entire 5 units. And the nature of application of force over this component can be taken as the tensile force. The forces are acting outwards. The forces are acting in a single line, so they can be called as a collinear force. But both the forces are acting in the opposite direction, so that the entire component can be elongated. So if the component is elongated, the type of the forces can be called as a tensile force. And just imagine this is going to be a picture in which different kind of load is acting over the given specimen. The specimen is given in green color, which is nothing but a flat sheet, and there is going to be another specimen which is given in red color, and that is called as ram or punch. And if the ram or punch is applied over the given component, which is supported by means of two supports at a distance between them, it can experience different kind of loading. So can you imagine what kind of loading is applied over the entire sheet metal structure? That is the combination of tensile and the compressive forces. So when a ram moves towards the sheet metal and makes a bending action so that the sheet metal is bent, so the sheet metal surface or the cross section can be subjected to two different kinds of stresses. That is, in this mode, in the picture given, if the same kind of force is applied over the given sheet metal, in the top surface of the sheet metal, the force acting over the system can be called as the compressive force, whereas the opposite side of the sheet metal, that is the bottom side of the sheet metal, in this component, it experiences some kind of an elongated stress, which is called as a tensile force. So this is going to be the combination of the previous two diagrams, in which both the tensile force and the compressive force are acting together in the bending test, and this kind of test can be called as the bending test. This is going to be called as a different kind of stress application. So this can be taken as the example for a fatigue loading, so in which a time is taken as the x coordinate and the stress magnitude is taken in the y coordinate, and over the time the force is applied from the outer periphery of the component, and the nature of the force acting over the system can be tensile and compressive. So the component is subjected to a tensile or compressive, or the combination of tensile and compressive, and especially this component is subjected to a tensile force moving outwards, and it is a repetitive stress, so that a cycle is formed. A cycle or loading of the component is shown here, and this is going to be the perfect example for the fatigue testing. So we'll see the other concepts in the subsequent slides in the lecture part 2.